All right, ladies and gentlemen, we're going to get right after this. And what we're going to do today is we're going to start talking about some trig values, very specific trig values, specifically going to be the pi over 2 angle, or the pi over 2 angle, and the pi over 4 angle. So that's my goal today. I'm going to try to make this video as brief as possible, but this is a relatively long section, and don't beat yourself up if it ends up going a long ways and you got to take a lot of notes. Now, the first part we're going to really talk about is some review questions that you guys got from Mr. Leesman from the 4.1 section. I really don't have a lot of time to discuss these, but I'm going to pause the video, work out some answers for you, discuss them relatively quickly, and then move on. So hang on just a second. All right, and I got those answers really super fast, but let's kind of talk about them real quickly. The first question saying find the negative coterminal angle for 70 degrees. Remember that we're talking about we want a negative one, and we want to find the same place where it terminates in exactly the same spot. So 70 degrees, since it's in the first quadrant, I would rotate it the other direction to make it negative, and all I did was take 360 and subtracted 70 from it, and got negative 290 degrees. The second one, which is really important to today's topic, is about quadrantal angles. Quadrantal angles are the angles at which we separate the difference between quadrant 1 and maybe quadrant number 2. So the angle that's right in between there, that's not in either one of the two quadrants, is called a quadrantal angle. So an example of a quadrantal angle would be, say, pi over 2, the one going straight up on the y-axis, or pi, or 3 pi over 2, or 0, or we could even call it 2 pi because it's just got another name for it. So big ideas here for quadrantal, meaning just the lines that are separating the quadrants. Those are quadrantal. The last one, number 3, was asking for the angular velocity, which is omega. Omega, which is W, is about theta over time. And since this is in revolutions, we've got to express it in terms of radians because that's what thetas are always written in terms of. So I just multiplied 25 total revolutions times 2 pi, and it's 50 pi per minute. And that's how you'd write your angular velocity. Okay, now pushing down from those reviews, if you have to go back and look at those again, just pause the video, go back, take a look at it a second time. Our goal today is to introduce some of the information that's based on the unit circle. Now, the unit circle is going to dominate your trig life for quite some time now. So if I was going to give you any piece of advice, I would say fill out a really good unit circle, which you've been given, and do a great job of understanding how to find the trig values that are on there. This next stuff that you're going to be seeing from here on down, you're going to keep seeing it over and over and over again. Those people that choose not to understand it pay the penalty for it over the course of the year. So let's talk about first some triangle review stuff. Now, you've probably heard of these before, the 45-90 triangle and the 30-60-90 triangle. The 45-90 triangle, being an isosceles triangle, happened to have some very special characteristics, and they were that if you were given one of the sides, which was the isosceles part, then this side over here became x root 2, okay? You also probably learned, too, that the 30-60-90 triangle, the skinnier version of that particular one, was a scalene. You probably recognize that if you had the shorter leg across from the 30-degree angle and you had the 60-degree angle, you got that the side over here was 2x, and that the longer side was x root 3. Now, these two triangles become extremely important, especially since the fact that we're talking about 45-degree angles, or pi over 4s. 45s are pi over 4s. 30-degree angles, which are going to be pi over 6s. And 60-degree angles, which are going to be pi over 3s. Now, you're going to have to get that in your mind, that really when we say 30, 60, 90, we could really be saying pi over 6, pi over 3, and pi over 2. And it's just the fact that we're going to move away from calling them angular amounts and talk about them in terms of their radian amounts. Now, these relationships that you see right here with the 30, 60, 90 become very important in helping us consider some of the following things inside the unit circle. Now, consider a circle that has a specific radius of r. Now, I'm going to make this a particular right triangle. It won't be a 30, 60, 90, but I'm going to pick a right triangle based on Pythagoras and make it a 3, 4, 5 triangle. Really easy Pythagorean triple, and get the idea that we're talking about theta down here in this corner of the triangle, the one that is attached to the positive side of the x-axis and being measured in a counterclockwise way. That's what these two really important concepts are, is that's how we measure our theta. Now, if I was looking at each one of those considered ratios, you'd probably be like, oh, I could find x and r. The x amount would be the x dimension going out this way, and the r dimension would be this one, and this dimension going up and down would be the y dimension. So if I was going to do x over r, I'd be like, oh, it's 3 over 5. Or if I was going to do y over r, it'd be 4 over 5. Or if I was going to be y over x, it'd be 4 over 3. Now, you've seen these things before because you ended up taking honors geometry, and we ended up learning some ideas about sine, cosine, and tangent, and so forth. Now, you probably haven't seen the ones on the other side, which is just they're saying that it's reversed. That's 5 over 3 and 5 over 4, and this one would be 3 over 4. We'll talk about what these are in just a minute and what their basic expressions are really about. Now, being able to understand that the dimensions of the triangle are specifically related to the circle itself is where really trig gets its name from. The trigonometry is about triangles, but as it's expressed in a circle. Now, to make things a little bit easier, in order to make the trig ratios doable, what we're going to do in terms of making those trig ratios, we're going to put them on a unit circle. Now, what I mean by unit circle is instead of making that radius 5 and making it all based on a Pythagorean triple, we're going to make the radius 1. And this is the reason why it's referred to as a unit circle. Okay, so the first place we're going to look is we're going to look at the quadrantal angles, and then later we'll talk about how to look at the pi over 4 angles. But we're going to really focus specifically on getting just the quadrantal ones first. So I'm going to draw just a set of crosshairs here and a very rude unit circle. And I'm just going to say that if the radius was a distance of 1 over here at an angle of 0, or pi over 2, or 2 pi, I would say that the coordinate at that location right there, and I'll put a big old fat dot on that, that's one of the quadrantal angles, would be expressed as 1, 0. It's 1 unit out, and because the circle is of 1 radius, and it is up and down none. So we'd agree that that's at 1, 0. Now this guy over here would definitely be at 0 and 1, straight up above, or this is at pi over 2. This coordinate over here, which is at pi, would be at -1 and 0. And then down here at 3 pi over 2, which is all the way around down this spot, would be at 0 and -1. Okay? Now, the first thing I want you to do about these particular pieces of information is I want you to put this on your unit circle. Okay? You have a nice, big, beautiful unit circle, and I'm going to show it to you. Same one that I have too as well. And here is your big blank unit circle that you've got. Now, we're going to be filling this in as we go along here, but the ones that I've only done so far at this point in time are the quadrantal ones, and that's the 4 in the corners of what we're talking about. So this particular one over here happens to be at 0 degrees, and the second line happens to be for the radian amount, which would be 0, and that's at 1, 0. Okay, so we've got the coordinate, we've got the radian, and we've got the angle. Now, there's 2 of them here because this is also 360 or 2 pi, and that's the only one that has a doubled up like that, so we understand that the full rotation can turn out that way. Now, I'm going to push this up just a little bit, get this next quadrant up here at the top, which would be 90 degrees, or pi over 2. Sorry, I'm putting an extra line in there. Pi over 2. And this coordinate would be at 0 and 1. All right? Now, what I want you to do is I'm going to pause the video for a second. You want to fill in the other 2. All right, and I filled those other 2 in That being pi and 180 and negative 1 and 0, and this guy being 3 pi over 2 or 270 degrees, and 0 and negative 1. Now, I'm going to flip back to our notes that we were just taking. If I can find them. Oh, they're up a little ways. And I'm going to continue from right here from where we left off. Now, the important part here to understand is with your unit circle right nearby, the reason why we made the radius 1 is because it helps us simplify some information about what your x over r is going to basically be. So if let's say, for instance, we were sitting at, if they end up becoming this, if you get the 1 that goes inside of each of these r's right here, it ends up simplifying the concept that we really could think that cosine of theta, whatever the angle happens to be, is really relatable to the x amount and the x amount only of where the coordinate ends up. So this is probably the most important thing to get out of this starting section, is that when we say cosine, we really mean x, okay? And when we say sine of theta, we really mean y. Now get those two things basically in your head. Cosine really means x, and sine really means y. That's a number one thing to go on here. Now tangent, on the other hand, is still going to stick into the idea that it's y over x, or if you want to think about it, y's real name is sine of theta, and x really is the concept of cosine of theta. And you can really think of tangent as sine over cosine. So get this in your brain, that the ideas are that cosine is x and sine is y, and later we'll really start talking about tangent as being, oh, that's sine over cosine. Now what we're going to do is we're going to look specifically at this location of 0. So it's saying, hey, find cosine of 0, and that coordinate that was there was 1 and 0. Now the answer to cosine of 0 is saying, okay, go find cosine when it's at the 0 angle, and if I say I'm looking for cosine, then I'm really looking for the x amount of when it's at that location, and the x amount is 1. And that's why we would get an answer of cosine of 0 to be 1. Now I'm going to go different color, and it says, okay, now go find the sine of 0, but sine says look for the y component of that particular coordinate, and that would be the sine of 0 is 0. Now, last but not least, if we were going to do the tangent concept, I would think that it's whatever the answer is for sine of 0 over the answer of cosine. I'm making all kinds of mistakes there. Cosine of 0, and that answer was 0 over 1, which is the answer 0. And that's where tangent's answer would be coming from. Now, the funny thing about this is that these answers recycle themselves. So if I went all the way around the circle and I went to 2 pi instead of going to 0, I still end up on exactly the same spot. And since that answer is still the same location, these answers, they do not change. They are repetitive, and they recycle themselves because the coterminal angle is going to be exactly the same amount because it's in exactly the same spot. Okay? Now, those 3 answers that you saw up above that were in the 1 column for cosine, sine, and tangent, they happen to have reciprocal partnerships that go with them as well too. So this answer right here with cosine was equaling 1 was because it was x was 1 and r was 1, and you can end up getting the reciprocals to them. Now secant is related to cosine. Cosine meaning that it's 1 over cosine of theta, of cosine of 0. And in this particular case, that would be 1 over cosine of 0. Cosine of 0 was already 1, so that's 1 over 1, so the answer is 1. And we write them all as reciprocal values. Cosecant, that's the CSC, is related to the reciprocal of sine of 0. Okay, and if this particular case, it was 1 over 0, and cosecant at that particular location is 1 over 0. Uh-oh, that is undefined. So that doesn't even have an answer at that spot. Okay, Now, cotangent is the reciprocal concept of tangent. So if I said tangent of 0, not theta, of 0, then I would be saying that that's 1 over whatever tangent of 0 was, which is 1 over 0. That is also undefined at that location. Now, it turns out in the quadrantal spots, there happens to be some undefined locations and 0 ones. You just got to keep track of those particular concepts, all right? Now, let's go down here just a little ways and fill out a little chart. Now, we actually did all these just now. So we did 0 and 2 pi, and we ended up with cosine was 1, and sine was 0. Tangent was sine over cosine, which is 0. And then we did each of the secant and cosecant ones. Secant is 1, cosecant is undefined, and cotangent was undefined, okay? Now, I'm going to help you with one more of these, and then I'm going to turn you loose to figure out what the other two are. Now, let's go to pi over 2, which is up here in this location, and I know that that coordinate is going to be at 0 and 1. Now, that particular deal, remember that's x and that's y, or cosine and sine, if the way you want to think of it that way. So cosine, and that's a good way to think, draw that up there. I'm going to put it up here. This is cosine, and this is sine. Then you would say, oh, cosine is 0, sine is 1. Tangent would be sine over cosine, which would be 1 over 0, which is undefined. Secant would be the reciprocal of this, which is 0 over 1. Flipped over would be undefined. Cosecant would be the 1 flipped over, which would be 1. And cotangent would be the tangent flipped over, which would be 0 over 1, which would be 0. Okay, so sometimes it might be helpful to kind of actually write these as their radius things here, like this is over 1, this is over 1, and so forth. Okay, if you can see it that way, it makes the reciprocals a little bit easier. Now I'm going to pause the video right here. What I want you to try is pi and 3 pi over 2, and get those coordinates, which are at -1, 0, and 0 and -1, and see if you can fill out the rest of this chart. All right, now remember that the key things that I was really thinking about is that when I'm looking at the cosine one, I'm really looking for the x. And when I'm looking at the sine one, I'm really looking for the y term of each one of those coordinates. And when I'm looking for the tangent one, I'm really thinking about putting sine over cosine so that I can come up with that answer. Now, you have to pause the video at this particular location and kind of look at those lines to make sure that you've got the right idea of what they should be and that you've got the coordinates and the radian values written in on your unit circle. That would be really super helpful. Now, you probably will notice that there happens to be some alternating concepts that go on with when one is undefined and when it's not, and so forth, okay? So pay attention to those patterns. They might be helpful in helping you determine what your quadrantal angles are. Now, if you have to, again, pause it, look at that table until you got it right. I'm going to push this guy down here now and say, okay, let's push a little bit further and past the idea of quadrantal angles because they always end up dealing with 1s and 0s. But what if you were actually at a specific angle that was somewhere in between those quadrantal angles or somewhere within the quadrant? Well, the first one we're going to talk about is we're going to place some points at your pi over 4 angles. Now, this pi over 4 angles, or your 45-degree angles, are going to be very important because they're going to use a unit circle concept that's going to use this particular 45-90 triangle. Now, the problem that we really got to be focused on is that this particular coordinate right here, the radius is 1, because on your unit circle, it's a radius of 1, which would make the dimensions of the two sides root 2 over 2 is where they end up coming out to be. Okay? Now, those are the dimensions of both x and y. Now, I'm going to go to your unit circle here, so I'm going to pause just for a second and flip over there. And here is your first unit circle. Here's your unit circle concept. Now, what we're going to do is we're going to tackle that 45-90 triangle. And what you really have to recognize is, I'm going to do this really lightly so that it doesn't end up messing up some of the other pieces to it, is you've got to recognize that there is a 45-90 triangle right here on your unit circle. Okay? Now, that angle that's being measured right there is theta, and that theta degree angle is 45 degrees. Now, that's going to be this middle one right in the middle of your quadrant. It's going to be recalled as pi over 4. And if I was going to talk about this coordinate up here, and it's an x and a y concept on your unit circle, then that would mean that this x dimension right here, seeing that that's a unit circle and that's 1, that this x dimension right here would be root 2 over 2 in terms of dimension, and that would be root 2 over 2 right there. Well, it would also be root 2 over 2 going up, and that would make this dimension root 2 over 2 as well. And that's the name of that coordinate in that spot on the unit circle. Okay? Now remember, we call them x and y, but they also could be think of that this is what cosine is and this is what sine is, because it's cosine is x and sine is y. Get that in your brain. Okay? Now, what I'm going to have you guys do is I want you to roll over here to the other 4590 and recognize that this one happens to be 135 degrees, or 3 pi over 4. And a lot of people are like, how do you know the fractions so much? I'm like, that's a fourth. This is 3/4. That's full 1. That's 1 pi, right? 1 pi. That's 3/4 of the way. So it's all about recognizing fractional notation of what's going on. That's 3/4. This would be, again, root 2 over 2 and root 2 over 2. But unfortunately, you'd have to go a negative root 2 over 2 in the x direction and a positive root 2 over 2 to get up to that value. Now, I want you to think about what's going on there, okay? That is going to be the zone that's going to be negative and positive. Maybe you might write that. This zone is negative and positive. These are positive positives. And then if you go down here into the third quadrant, this is a location where it's going to be negative, negative. And this is going to be positive, negative. Now, I'm going to pause the video. I want you to fill out this 45 and this 45 with the correct values. You know, it makes me laugh when I actually fill these out myself, too. I did the radian part and the coordinate part without any question, but you know what? I actually had to grab my calculator to figure out what the other angles were. And the reason behind this is because over all the years, I've ditched the idea of degrees. So will you. It'll be an amazing day for you when degrees become irrelevant and radians become everything that you live by. But notice that these are both negative, negative, and that one is positive, negative. That one's 5 pi over 4, or 1/4 past 1, 1 1/4. And this is 7 pi over 4, or 1/4 shy of 2 pi, which would give you that particular idea there. Now, some people will try to memorize how they get the actual coordinate, how they get the radians here. This one's 1 smaller than the bottom. This one is 1 bigger than the bottom of over 4s. This one happens to be 1/4 shy of the 2 pi. So if that helps you a little bit, go ahead and use that. Now, flipping back to your stuff on your notes, now I can actually go ahead and start to think about what the answers are for finding any answer that's in pi over 4. Now, the funny thing about pi over 4s is they're going to always incorporate using a root 2 over 2 combination of what's going on. Every single one of them has a root 2 over 2 combo. So cosine, I'm going to point that coordinate right up here of pi over 4, and it's in the first quadrant. It's going to be root 2 over 2 and root 2 over 2. That's what that value is going to end up being. And if I use my unit circle, I'd recognize, oh, that's root 2 over 2. This is root 2 over 2. If I thought about sine over cosine in this case, sine over cosine, I'd basically be putting this value over the top of that one, and they'd be exactly the same. So that answer is 1. Good job. Now, if I turned this particular concept upside down and did its reciprocal, it would end up being 2 over the square root of 2. Now, that is not good because we have to rationalize that. And I'd multiply by root 2, and I'd end up with 2 root 2 over 2, which would only be root 2, because you'd cancel. And then that would be the same exact answer for cosecant, root 2. And cotangent would be this guy flipped over, and that's 1 over 1, so cotangent would be 1. There you go. There's your answers for the 45-degree angle. Now, remember that when we move into the second quadrant, or quadrant number 2, the coordinate that you're dealing with is going to be negative and positive. So that would be helpful in helping determine what the answers are for sine and cosine as we go down the list. Cosine would be negative root 2 over 2. This would be root 2 over 2. This one over that one would be negative 1. These would be reciprocals, but they'd change their sign. So negative root 2, that would be positive root 2. And this would be the flip over of that, which would be negative 1 as well. Now I'm going to pause the video. You fill out the other two, which are going to be of a negative nature and of a positive negative nature, and see if you can fill out these two lines. And that's what the bottom two lines should look like. And ultimately, it's all about just finding that coordinate, recognizing again that cosine is x and sine is y, and tangent is sine over cosine. Get those in your brain. I keep saying it over and over again because it becomes a very important concept of what you're going to be doing. Pause on that part of the video if you need to get that particular chart filled out. But let's push on down here to some other coterminal concepts that are going on there. Now, the funny part about trig is that when you go around these unit circles, you're just like, whee, around the unit circle, and you end up in the same individual spot. The funny part is that that coordinate doesn't actually change in the unit circle when you circle all the way back around. And what that means is that this is what's referred to as having a periodic concept to it. It happens in every certain amount of cycle that you end up coming back to the same location over again, okay? It turns out that cosine and sine, specifically those two, I'm going to put a star on these two, have a period of 2 pi, meaning that you have to go all the way around the circle one full time to the same coterminal spot for it to repeat itself. Now, as a direct result, cosine causes secant to be 2 pi as well, and sine causes cosecant to be 2 pi as well too, because they are their reciprocal values. So the key here is that if you're dealing with something that has a 2 pi revolution in it, you can unwind the rotation until you're in the exact coterminal spot. So cosine of t is going to be the exact same amount as the cosine of t plus 2 pi. But it's not just every single 2 pi. It could be 2 pi once and then another 2 pi again, or 4 pi, or 6 pi, or 8 pi. So what we put here is we put 2 pi k. And that k stands for an integer that is between 1 and infinity. And that just tells you how many extra rotations we're adding on. Now, the funny part is we could actually say that cosine now of something like 4 pi is exactly the same thing as the cosine of 0. Because you unwind it to that same location, it's the same coterminal location. And this works for all of them. Sine of 2 pi k, secant of 2 pi k, and cosecant of 2 pi k. Okay? So the key here is remembering that those four have a 2 pi period is what's going on there. Remember that that's called its period. Now, I pull apart that there are two others, tangent and cotangent, who kind of sit out apart from themselves. This rule applies, but the period for each one of those two is a little different. It's only pi. You only have to go half of a circle before you end up repeating the concept of tangent and cotangent. So I'd say that tangent is pi k and cotangent is pi k as well. And you only have to go half as far to get those guys to repeat themselves. Now, those actually do show up in these charts right here. As you can kind of see, it only took a pi amount for tangent and cotangent to actually start repeating themselves. All right? And that is the reason why they turn out that way. Okay? Now, how to determine whether or not they're positive or if they're negative. Okay? This particular deal right here all boils down to a very easy chart to understand, and this is going to be a very big piece of what you want to learn here, and that is the ASTC chart. Okay? I actually refer to it as, like in an acronym, all students take calculus. But Mr. Leesman will probably remember it as, adults shouldn't touch children. Okay, if that makes you laugh, then at least you got a laugh out of the video. Okay, now what it means is that the A stands for all, is what it is. And what they're saying here is that in this quadrant, all of the trig functions, sine, cosine, and tangent, are all positive. Sine, cosine, and tan are all positive in this quadrant. And it makes sense that they should be. Their x's and their y's will all be positive combinations, and it should turn out that they should all be positive. Now, the only one positive in the second quadrant is sine. Sine's the only one positive, which would mean cosine and tangent are negative there. That makes sense. Cosine being x would make it go in a negative direction and automatically cause it to be negative. Okay? Tangent happens to be the only one positive in the third quadrant, and sine and cosine are both negative. And in the fourth quadrant, only cosine is positive in that particular quadrant because you're only going in a positive x direction, but the y's are negative, all right? ASTC, adults shouldn't touch children. Okay, it's a good analogy. You should definitely go by that. Okay, now, what I'm going to get down here to next, is I'm at like 31 minutes for this video, is I'm going to do a few of these problems and then just show answers to how they ended up turning out to be this way. What the key here is that every one of these has a very ugly radian concept on the inside, and the key is to unwind them to their coterminal locations and then find their answer. Okay? So remember that the period for sine and cosine is 2 pi, and tangents is pi. Now I'm going to show you kind of like the first couple of concepts to see what's going on. And this particular one right here is saying negative 11 pi over 4 has been rotated out. Well, this is going the wrong way. And what you're going to want to kind of start to remember is that 2 pi in fourths is 8 pi over 4. You're going to kind of want to start thinking about 2 pi in all kinds of different fractional ways. And you might want to think about pi as being 4 pi over 4. Okay? And the reason behind that is because if I think about 11 pi over 4, then that means that it probably went around all the way around to negative 8 pi over 4, and then it went a little bit further. How much further did it go? Well, it went a negative 3 pi over 4 further, and that particular answer is going to be down here in the fourth quadrant. Now, the question boils down to, what's the coordinate in that spot? Well, it's a pi over 4. It must be a root 2 over 2 concept in both of the cases, but it's in the fourth quadrant, which would make it positive and negative. Now, which one of those is cosine? It's looking for the x part. So the x part would be root 2 over 2. Okay? Now, the key here is to draw yourself a decent picture of where it ended up and then find its answer. Now, if it's a reciprocal one, don't beat yourself up. It's going to be okay. 9 pi over 4 is going to get you to rotate beyond into the first quadrant further than 8 pi over 4, which is 1, 2 pi, and another pi over 4 there. And I'm going to get an answer for root 2 over 2 and root 2 over 2. But cosecant is related to sine. It's 1 over sine. So once I find the answer for the sine of that location, and then I get its reciprocal, that's 1 over root 2 over 2, because that's the y. And if I reciprocate it and flip this over, it would be root 2. Now, you can use your charts up above, or you can use your unit circle to help you through these, but I am going to do these 6 problems when I pause, and then you can check to see if you did them right. All right, now I did a couple of these. I did 3 and 4, and I did 5. And I just want to kind of talk about each one, just rotating this guy out. I got 5 pi out of 4 by taking 8 pi over 4 out of it, and that gave me the 5 pi over 4 and found its value. Also recognizing that it lands in the 3rd quadrant, and all students take means that only tangent is positive in this one, so I knew it was negative root 2 over 2. The 4 pi in number 4 is irrelevant because it's just extra rotations. It's like going around once, going around again. I still end up at pi over 4, so that doesn't make any difference. So if you have even rotations, they're just revolutions that have been put in there. That's like 9 revolutions is really what's going on in there. This will end up at 3 pi over 4, 1 over cosine of 3 pi over 4. 3 pi over 4, cosine all students. 2nd quadrant, cosine is negative, so it should be negative root 2. Now, cotangent, this one is a little funky here. Cotangent has 31 pi. This is irrelevant too as well. Even though it's an odd amount, the cotangent has a period of pi. So it doesn't matter if it's a half of a rotation further, that doesn't really come up into play. This is just cotangent of negative pi over 4, or really the same thing as cotangent of 7 pi over 4, because it's in the 4th quadrant. All students, and this is probably where we really need to start talking about this, all students take calculus would mean that over here only cosine is positive, not cotangent. So this answer better be negative. And whatever the answer is for 1 over the tan, and tangent in that particular spot would be cotangent. I'm going to go up to my chart. That one I haven't done in a while. So the cotangent at 7 pi over 4 is negative 1. And that would be my answer. I checked my chart. Okay. Sometimes you run into ones where you got to slow down, pause just for a second. Now this one might have a negative on the outside. That only comes into play at the very end. So it's not relevant. It's not relevant until that time. Now, negative 11 pi, the tangents period is pi. So those are irrelevant concepts. Sine tangent, negative tangent of 7 pi over 4. 7 pi over 4 is going to end up being, okay, now let's see here. We're in the 4th quadrant. All students take calculus, so it must be negative, and tangent is 1 or negative 1 in that location. So this would be a negative times 1, negative 1, excuse me, okay, because it's in the 4th quadrant, and a negative would make it a positive, okay? Check your answers out. Make sure I did that right in that chart. Is tangent negative 1 in the 4th quadrant? Oh, it is. I did good. Okay. Down here to the next set. I'm going to pause again and let you guys work on some, and then we'll get down to that last one. And a little check of your answers that are going on there. If you have questions on some of these, ask your instructor during class. Bring out your notes and say, hey, you know, how did you do that specific one? How did G do that specific one on the notes? Most of these are just cancellations, like the 300, you cancel it out. It's just rotations. This one I added 24 pi over 4 because that's 6 pi. I was just trying to get it in the same coterminal location. 6 pi on this guy should be canceled out. And I ended up converting it to its positive radian. I just like to deal with positive radians, and probably so do you. This one, 13 pi, ends up landing on pi instead of coming all the way back to 2 pi. So it's just really sine of pi, and sine of pi is 0, so that doesn't make any sense. And then we'll go down here to the very last one. And this very last one is really not so hard, as it's really just 3 separate problems that you're really trying to figure out. So work them all out individually, and we'll see if you can get it right. And here's what I'm going to basically say. I converted all the ones into their coterminal locations, and I really want to focus on how to use this ASTC piece. Sine of 5 pi over 4, well, we know that over 4 ones are going to be root 2 over 2, because that's just a signal to you that you're going to be basically getting an answer of root 2 over 2. That's just the case. Sine and cosine going to be root 2 over 2, no matter what, if it's at a pi over 4 location. The key is to understand where it ends up landing. 5 pi over 4 is going to land in the 3rd quadrant, and only tangent is positive down there, so this must be a negative. There we go. Cosine works the same exact way. I know the answer is going to be root 2 over 2 because it's a pi over 4 reference angle. 7 pi over 4, on the other hand, is going to land me in the fourth quadrant, which would make this guy positive. And then tangent, last but not least, is tangent is 5 pi over 4 is going to be positive. Now, tangent at the pi over 4s is going to be 1. It's going to be any of them. It's going to be 1 or negative 1. So I know the answer is going to be 1. But since it lands in the third quadrant, I know that the answer is going to be a positive 1, and this answer would be 1. So what you really need to do is take this whole phrase that you got right here, print it out real nice and big, put a hashtag on the front of it, and put I am on it, and then this, and it'll be I am number 1. And you'll be the only one who gets it. All right, I hope you've enjoyed the video, and get lots of questions out there to your teachers. See ya!